clear about, but they never ask me until it's after the test and stuff. So do you understand why that's in the hundredths place? There's always a question about, if I broke it, isn't this equal to 0.2 plus 0.07?
Yeah.
Or if I do 0.2 plus 0.07, don't I get 0.27?
Yeah.
All right, let me stop there for a second. What's up? What's the matter? So how do you add decimals? So that's what that's leading to. How do I add decimals? So if I said, what's 0.04 plus 0.3? Is that some kind of 7?
No.
You see why somebody would think it might be a 7? Because they see a 3 and a 4, but are they in the right place? It's the same thing as me saying, what's 30 plus 4? Is that 70?
No.
No, because you put the 4 here, of course, but what are you lining up? The decimal. So you keep doing the same thing we've been doing. So if you put 0.04 there, you better put 0.3 there. What's understood to be here?
0.
Kick ass. Real quick, word about that, real quick. 0.3 is 3/10, right? What's 0.30 officially? 30 over 100. Well, what's 30 over 100 reduced to? 3/10. That's why you can add on as many zeros as you want to after a decimal, because it would reduce to the same number. I like it. So math doesn't give a shit how many zeros until I go, zeros until I go insane.
Okay.
And math is like, wow, good job. You didn't do anything. All right. So then here I would get 0.34, right?
Yeah.
All right. So now watch. What is 0.2 as a fraction?
2/10.
2/10. What is 7? What is 0.07 as a fraction? I always just said it. 7 over 100. Can I add those as fractions? Right now, are you able to add them right now? What do they need?
The 0.
Yeah, so I can multiply this by 10, right? So this becomes 2,700. So there you go. So 0.27 is 2,700. So my point with that is, the number that's in the last place controls what place it's in. So that's in the tens place, that's good for it. That's in the hundreds place, that's where the 27 is. It's in 2700s place. In the hundreds place, yeah. Maybe. I don't even know if I need to say that, but it's always something that comes up later that I'm like, oh man, I wish you would have said something. Okay. So let me give you a few to try, and I'm going to pull up the book here. So rewrite these in fractional form. So what's this first guy here? What place is he in? Thousands, tens, hundreds, thousands. I love it. So it's 102. So if they say write this in words, and a lot of guys miss that, read the instructions. But they say write in words, all I gotta do is write it in English. So this would be 102 thousands. Got it. I like it. Has anybody here never written a check? Or not know what a check looks like? So like this last one, if this was a check for $1.03, that's a good check to have to write. when you write on the line where you have to write it in words, where do you use the word and? Decimal. That's what it's supposed to denote. So you never use the word and unless you have a decimal there to let people know about. So notice I didn't say 102 thousandths, because that would mean 102 thousandths. Do you see that? It would mean 100 and 2 thousandths. Oh shit, that's not what I meant. So I don't want to use the word and, because that's where the decimal is. So there is no and in here at all, because it would be and that doesn't make any sense. 0 and. So I don't need it. You guys see that? Be careful with the word and. It denotes where the decimal is. So it changes totally if you use it the wrong place. So let's do this one since we're talking about it. This will be 1 and 300ths. 1 and 300ths. I like it. In words, it'll be 1 and 300ths. Is that cool? Just like you would write it on a check, if you are filling checks out correctly. As long as they take it, right? As long as it doesn't bounce. Alright, and what about this last dude? What would it look like as a fraction?
2 over 10,000.
10,000, I like it. And you can always do this, this always works. 1, 2, 3, 4. 1, 2, 3, 4. Right? And then you'll get it. That's another way to look at it. It's a divide by 10, divide by 10, divide by 10, divide by 10. So divide by 10,000 total. And if I ask you to, you should be able to reduce anything that you get, but the real important thing right now is how do you get that fraction in the first place? In words, this would just be 2 10,000ths. Only use the when it's a number less than 1. It's a true decimal number. I like it. 2 10,000ths. I like it. Alright. Let me pull this up real quick. By the way, somebody pointed out to me that the link on the website had changed. It didn't go to the book still, and they had changed the textbook link. So now it's updated. So if you click the free textbook link, it should take you to that OpenStax at the right place. I don't know.
20 minutes last night to load over.
So you gotta re-download it?
No, I just changed the link. So if you go to the link on the website, hit the free textbook link, it goes to the right place now. You can just hit the chapters that I have, and they're the actual chapters. They're on my website. But that free textbook is a link to the website with the textbook on it. So if they change links, I'm like, oh shit, I gotta go change links. Okay. Just want to make sure I don't lose anybody. Oh, okay, here's the thing. Good. I wanted to see where this was. Rounding decimals. Just like rounding numbers. Let me make sure you guys can round numbers in the first place. Round 42,771 to the nearest hundred. What number is in the, well, I know there's a couple. Where's the hundreds place? Yeah, there's first 7 here, right? So that's the number that I am going to leave alone or increase. Those are my 2 options. So I look at the next number, and since that number is 5 or more, make that go up to, so instead of 771, I'm not going to put 800. 771 is closer to 800 than it is to 700. That's really all rounding is. So if I say rounding the nearest 100, well, which 100 is this closest to? 800. So I'm going to make this 42,800. How are we doing there? Remember that whole thing? You look to the next number. If it's a 5 or above, you go up. If it's a 4 or below, you stay. Well, it sounds like you're in Vegas. Stay. Right. If it's 5 or higher, you got to take that. So if I said round 518,997 to the nearest 100,000. What's in the 100,000s place? 5. What's the next number over? 1. So is this closer to 500,000 or 600,000? 500,000. Next number's a 1, so I keep it where it is. So it's 500,000. Now I've had a student tell me the answer was 5 because you keep it as a 5. So I'm like, you're not going to estimate this many people to be about 5. Yeah, we just need 5 chairs for this concert. No problem. I know. Get a lot of people standing, angry, swaying. All right. So not 5. Go away. I like it. So, what about decimals? Well, they work the same way. So if I said round 4.8273 to the nearest hundredths, all you got to do is know which spot I'm talking about. So which number is it that I'm going to change or keep the same? 2. The 100th spot is right there. So I'm either going to keep that at 2 or I'm going to make it a 3. So what's the answer going to be?
4.8300.
Yeah, and you don't need the zeros, right? Because math is like, now if you put them there, I'm not going to take points off, but they're unnecessary.
Round 8, round 8.
Well, the 100th spot. So I'm going to round this. That 2 is in the 100th spot, right? Hundredths.
Right.
So the next number, since the next number is 5 or more, I'm going to take that up to a 3. 4.8273 is closer to 4.83 than it is to 4.82. I like it. That's all rounding is. So rounding decimal places, the only thing that you got to be careful at is which place are you looking at. You got to know your places, and then you do the exact same thing you always do with rounding. How you guys feel about that? It all depends on how good you are at rounding at this moment. The better you are, the easier that is. You want to try a few? Let's try a few. Round. Hey, then just round. To the nearest. Nearest? Good job, John. Nearest. Say tenths. Tens. Let's see here. Thousands. Let's try this. You like that, Jesse? It's all about locate the place, look next to it, decide whether to move that place up or down. Or I'm sorry, up or leave it the same. Yes? That was 5 or more, so I took that up to 3. If that would have been 4 there, or 3 or 2 or 1 or 0, I would have left that at a 2. That's how rounding works, right?
Why do you got the chance and the chance?
Because they're 2 different places. That's why. Five or more, yeah. Yep. We'll make that number change. 4 or less, we'll keep it the same.
I don't know.
I was almost careful. Oh well. So what number is in the 10th spot?
7.
How about the 9?
10th. So because it's got a lift,
6.
where is it? It's after the decimal place, right?
2. It's in the 2.
2.
Oh, my.
The 6 is in the hundredths place.
Uh-huh.
Let me let that sink in. So that TH is important. Don't just say tenths when you mean tens. They are different things.
Right. 10 would be.
Tens would be, the 9 is in the
Right,
tens,
going that way.
but the 2 is in the tenths.
Yeah.
I like it. All right, let me let that sink in. Now, one thing that throws people off is the ones. The 1 spot is in front of the decimal, so you can't say you go 2 out to the tens, so you must go 2 out to the tenths. Do you see what I mean? Don't think that way. It doesn't work that way. I don't know if somebody thinks that way, but sometimes I feel like people might think that way. But it's a little unfair. The reason it's unbalanced is because the 1s is on this side.
Yeah.
So on either side of the 1s is the tens or the tenths. Maybe. Yes, sir.
One question. On the 10s, with the list part, you wouldn't change that 1 over until you actually hit that 2 go all the way up to a 9, and then it would.
Okay, yeah. I'm going to focus that on that weirdness
Okay.
after we first learn rounding period.
All right,
Because where it gets weird is when that next number is like a 9 or something or weird. Yeah. All right, we'll see. So tenths, would I change it or leave it the same? Because the next number is more than is 5 or more. So was it 5? Yeah. Always the next number over.
3.
3, yeah.
Or 30 or 300.
3,000.
I don't care, right? The zeros you add doesn't mean anything. And again, if you just focus on this, all I'm saying is this closer to 30 or is this closer to 20? It's closer to 30. I don't need the 0, but if it makes you feel better, you can certainly have it there. Right? That's all we're doing. And that's why the rule is the way it is. If it's 5 or more, it's closer to 30. If it's 4 or less, it's closer to 20. That's why we do what we do. That's all rounding is. Tens. What's in the 10 spot?
This is the 9.
It's the 9. And the next number is a 1.
So 590.2.
Yeah, 5, 9, 0.
You're gonna have to put the 0.2.
Definitely not, because then it's not rounded to the tens. If I say rounded number to the tens, it better be a round number. You wouldn't say 80.7 is round. It's not rounded. So yeah, anything after the spot that you rounded to would become
You
zeros.
don't have to put all that other crap after that.
Yeah, no, because they go away.
Okay.
Yes.
Okay. That is a 1, right? After the 9.
Yes.
So
So it's 4 or less. So I keep this the same.
Huh?
Is that cool?
okay.
So again, what I'm saying is 591 point business. Listen. It's either going to go to 590 or it's going to go to 600. Oh, that's the weirdness, right? So what's it closer to, 590 or 600? So if I made that a 4, it's still closer to 590. If I made that a 5, oh shit, now it's closer to 600.
If you made it a 5, it's what?
Closer to 600.
Oh, yeah, it's a 1.
Oh shit. Thousands. What's in the thousands place?
The 1.
The 1.
Yeah, 1.
So it's either going to be 591.261 or 591.262.
591.2.
2. Because the next number is a 7. 5 or more. 591.26. 2. I like it. Good. All right, let's talk about that weirdness that sort of showed up there. Round to the closest ones. Let me just say. Round to the ones. So where's the ones?
The 9 in
Yes.
front to the left.
What's the number right below 9?
10.
8.
8. What's the number right above 9? 10.
Yeah.
Right. That's where the weirdness comes in. So it's either going to become 580, 589. It's going to stay either. It's going to stay 589, or it's become 590. It's one of those two.
590.
And since that number is a 9, it's going to become 590.
5.
That's the weirdness that somebody was mentioning earlier, is when you have to actually change the next number over 2, because the whole speedometer, the whole odometer thing is going to have to roll over, right? If I got to 7,999 miles, what's it going to click over to next? 8. It's going to change that number way the hell over there. Of course it is.
8,000.
So that's, if I'm around at this place, I might have to change that number sometimes just because it's right on the edge of the next number up. I like it, baby.
All right, what if that 2 on the end was a 5 instead?
This problem would not care about that number at all.
We wouldn't care about
It
that?
doesn't care about it. Oh, I like this. Here's a big mistake that people make. If I said round to this place, and somebody says, well, that's a 5, so that would be 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 a 5, so that's a 5. Yay! That's crap. That's a neat. Well, there's more choices than that, but yeah, that's one possibility. That can't affect stuff way the hell over there. I look at the next number over, it's a 4, so it becomes 4.4.
4.4.
You don't say that would round to 5 and that. I mean, if I said round to this place, what would that become? If I said round to this place here. What's happening? If I said round to this place here. The next number's a 5, so this would go to 5. Do you see what they're thinking? So then they say that would be 4.4, 4, 4, 4, 4, 5. Now if I say round to this place, that would become a 5. Then that would become a 5. Then no. That's several problems in one. The minute you round it, it's not the same number as it used to be. So you can't do something else on top of that. You choose one place to round it, so you can't say round, now rounded it, now you got an entirely different number. You gotta be careful. Okay. So that's a little bit of weirdness too, that you reminded me about. Yes?
Why does it remain 4.4 if the fours, like why doesn't it go down to 4?
What's that? So if I want to round to this place, to the tenths place, the next number is a 4. So does it change or does it stay the same?
It doesn't go down.
Good. So it's 4.4. Cool. I like it.
It doesn't go to
If you're
0.
rounding
Yeah,
off,
it doesn't go to
It doesn't
0.
go to 0?
you just said 4 goes lower.
If I said-
lower than
all
5.
All right. Let me ask you. Round this to the tenths place. Where's the tenths place?
Right there.
Here. So that's the number that's either going to stay the same or go up. That's the only options you got. Why is it going to stay the same? Because the next number is not a 5.
Right.
So it's 4.4. If I said round to this place,
If the next number was higher, then it would go up.
yeah, that's 4, so it just becomes 4. I like it.
40.
So the place that I say to round to is the place that could change or stay the same. Nothing else.
This always on the right of this one?
Oh yeah, these are the this.
This?
Yes. And these are the pure tens, hundreds, thousands. These are the tenths, hundredths, thousandths. Yeah. All right. What was the weirdness? Oh, good. Okay. Let's see. So we've already talked a little bit about adding. We're also going to talk about subtracting. So take a minute here and do this for me. Add
Don't lie.
11.983. Add that to 2.76. Add those together. By hand, hopefully, obviously. By the way, on the
Oh,
homework,
we have to add them?
if you're using a calculator where they say stuff like this, you are not helping yourself. Right? I'm going to want you to do this by hand. Hopefully you understand. This is not push the right button class. We'll find out. Yeah, I'm sorry. Add this to this. My bad. You have to listen for 1 second. So the only difference between numbers with decimals actually present versus just whole numbers is what do you have to make sure happens? Line up the decimal point. You can't just put 2.76 here. It's got to be 2.76. And if you want to, sometimes you have to do this, but you can add zeros until they're actually the same length. Does that make sense? Because you can add zeros anytime you want to, and this is a good time to do it. So then you add these, what do you get? Yeah. 3, 4, 7, 4. And where's the decimal? It's the nice thing about lining it up. It lines itself up to where it's supposed to go. Gas. Alright, so what about subtraction? The thing about subtraction, let me just do this problem, see what you guys do. Do this problem. Let's say 51.93 minus 9.876. Ooh, yeah, that's. Oh, if I make that sound, you know it's going to be a little gross. Line up the decimal. That's the trick here. Just not going to be enough numbers first. Let's go 9, 3. Now it's got 8, 7, 6. You have to add a 0 to that number. You see what I mean? Otherwise it would just be empty space. So let me make sure everybody's got the first step correct. So if you do 51.93 and then you got minus 9, so you put the 9 here so the decimals line up. 876, what is wrong? What's kind of needs to have something happen?
Put a 0 on
You
top.
gotta put a 0 there.
Yeah.
The zero's going to change to
Say again?
The zero's going to change to
Oh yeah, now you attack it like always. Now you attack it like always. That's the only difference between decimal numbers and whole numbers is sometimes you have to add zeros in. You would never do that with a whole number. When say I don't like 4. Maybe add a 0, make it 40. You can't just do that. Adding the 0 doesn't change the number though. There really is a 0 there. And now you just have to be able to borrow and stuff correctly. So of course you really have to start borrowing here, right? If you borrow, let's see, if you borrow from this guy, but now you got to borrow from this guy, right? And if you really want to, yeah, sure. I like it. So see, that's 5 whats? 5 10s. So if I put a 4 there, where did the other 10s go? Right there. 10 plus 1 is 11. I mean, that's why borrowing works, right? All right, and then now you just do it. All right, so you get 4, 5, 0, 2, 4, 42.05. What's up? Oh, okay, good. I like it. Everybody else is like, it's nice for you. It's cash money. That's right. Let me see if you guys. Let me show you one little trick with that, especially with the do 1 minus any decimal. So if I had to do 1 minus 0.4592. Now watch. Before I just unleash you on this, because it gets gross if you try to do it directly. So this would be 1 point, well let's see, minus 0.4592. So I need 0, 0, 0, 0. I got borrowing up the yin-yang, right? So, I don't know who remembers this. I think I showed you this cool little trick. 10 minus 6 is what?
4.
If I take this down by 1 and I take this down by 1, it's going to be the same answer, of course, because the distance between the numbers stayed the same. Now watch. This is a cool little trick. I know you guys are about, I got a calculator. Not always. So if I make this become 0.9999.
No.
Yes. guys still with me?
Yes.
How did you make it?
If I make that just, how did I make 10 become 9? I'm just saying, it would still be the same answer at the end. So if I ask you to do 10 minus 6, and you say it's the same as 9 minus 5, and you get 4, I can't argue, because you're right, it's the same. The distance between them is the same. Now if you don't like this, you could just borrow till you go insane. But if I change that last place by 1, I better change this last place by 1. This is not even the full shortcut yet. I just want to show you why the shortcut works. This is why the shortcut works. So stay with me. It's the same idea as this. If I take that down by 1, I can take that down by 1, and the answer is the same. So this answer is going to be the same as that because I took them both down by 1. And why is this easier? Because when I got 9s up top, I haven't got to borrow shit.
Yeah.
Right? So then I get 0.5, 4, 0, 8. Now you ready? Those of you still paying attention? Here's the ultimate shortcut. If I got 1 minus some decimal less than 1, what makes this 9? Guys, what makes that 9? 5. What makes that 9?
4.
What makes that 9? 0. What makes that 10?
8.
Make 9, make it 9, make everything 9 until the last one make it 10, and that's the ultimate shortcut on how to do 1 minus any decimal. If you have statistics in your future, maybe. If anybody has to take statistics eventually, that actually becomes really useful when you're dealing with like probabilities and stuff.